Okay, this is assignment 2.1.10, basically using a line follower to measure light and dark areas, basically. We're going to get started on this. For this particular project, we're going to just go straight to the actual line follower. There's no kind of way to do it in the virtual one first. So we're basically just going to hook it up and kind of use it directly from our real circuit and so forth. But basically the way it works is there's an IR sensor and an IR emitter, and they are basically kind of right next to each other. And the IR emitter sends out some infrared light, which is reflected back to the sensor. The infrared light is used basically because we don't want to have visible light kind of interfere with our readings, so we want to measure it on a kind of a different wavelength. So that's why we're using the IR wavelength. Very much so that, again, we don't get feedback from other light sources, basically. All right, so then based on the light hitting the sensor, you can determine if light is being reflected from a light surface or a dark surface. Basically, kind of how much is reflected back tells you how much light is coming into the sensor. And basically, this is kind of how your optical mouse works. So basically, when you have an optical mouse for school or for work or home, there's a kind of a laser that shoots out of the optical mouse. And basically, it gets reflected back onto a light-sensitive sensor, and then basically, kind of the variation in light, hitting and striking that sensor it tells the computer basically which way we're moving our mouse and so forth. So basically that's how an optical mouse works. Now an optical mouse of course uses a laser so that it gets a better, a more refined signal. But basically with our line follower we just really can only measure two states, either light or dark. It doesn't quite work the same thing as an optical mouse. So we couldn't use our line follower thing here as an optical mouse. Okay, so then for our project, basically we're going to set up the sensor to let us know when we've reached a black line, because again it's a line follower. So in this case our line is just going to be a short piece of electrical tape, and we're basically just going to kind of run the line sensor back and forth back and forth to make sure that it kind of can sense that black line. We'll figure out kind of like when does it cross the line, and then when does it not, or when is it on the line basically, and when is it not on the line. Okay, and again, since we don't have this similar parts in the virtual design studio, we'll be just wiring it up and coding it directly. So what we need for the parts for this assignment, we're going to need our Arduino board, our breadboard, a line follower module, an LED, a 330 ohm resistor, 4 jumper wires, and then we're going to need 3 other kinds of jumper wires that what we call male to female to kind of hook our sensor up with. So basically we're going to, our sensor actually isn't going to be on the actual breadboard. It's going to be kind of connected to the breadboard with some wires, but kind of loose so that we can kind of control it basically with our hand. And so, all right, so now it's time to start building the circuit. Basically, again, you're going to be doing this with real parts. Basically, we're not doing it virtually first. So start by connecting our 5-volt pin from the positive, or our 5-volt pin on the Arduino to the positive channel of the breadboard, and then the ground pin to the negative channel. That was what we do all the time. All right, now we're going to use some male-female jumper wires to connect to the line follower. So the female jumper wires are going to be connected to the sensor. So there's 3 pins on the sensor. All right, and then the male pins will be connected to different parts of our breadboard. So the ground wire basically is going to go to the negative channel of the breadboard. The VCC pin or the wire is going to go to the positive channel. And finally our out pin, basically, that's the pin that senses the light, so it gives us a signal out, and that's going to go to digital pin 4. All right, then we connect our LED to the breadboard. Again, this is very similar to how we've connected LEDs in the past. Basically, you're going to put your, connect your LED to the breadboard, then connect the short leg to one end of the resistor, the 330 ohm resistor that we need, and connect the other end of the 330 ohm resistor to the negative channel of the breadboard. Then you're going to connect the positive LED leg, basically, to the digital pin 9 on the Arduino. Okay. All right, so make sure to check your circuit with Mr. Hoover before moving on with the code, just to be sure that you got everything hooked up correctly. You don't want, if there's an issue or it's not working right, you don't want it to be the actual circuit. You want it to be your code that you have to go back and fix and so forth. All right, so again, we're going to start with the Codo's mantra of comment first, code last. Now, for this project, basically, I'm going to give you the story. I'm going to give you what you kind of expect, what we want to have happened here. And you're going to do all the coding yourself. So I'm going to kind of turn you loose on this one, and you're going to kind of do the coding yourself. All right. So you're going to start by writing the comments. So take the story here and basically change that into comments in your code. Again, add the functions that we're going to need. We're going to need a setup function and a loop function. Those are the only two functions we actually need for this. And then basically once you got all your comments in, then you can go back and add your code underneath your comments that correspond to what you're doing. All right, so in this project, we're going to basically use the line following sensor to light an LED. Now, when the line following sensor encounters a black line, you basically should turn on the LED, and when it doesn't, sense a black line, basically you should turn the LED off. Okay. Now we'll start by giving the pins we use in the Arduino for the Arduino some constant integer variable names to make it easier again to use later in the program, just like we always do. Now in the setup function, we're going to set some of the pins to input and some to output. Again, we want to set obviously the LED pin to output because we want to send out a signal to turn it on. But the pin that's coming in from the line following sensor, we want to set that to input because we're going to bring, that's we're going to be sensing information off of that pin. Okay. Now, the other thing you want to do is set up the serial monitor. Okay, so you know how to do that. We've done that many times. So set the serial monitor up also in the setup function here, because that way you will be able to then capture, be able to check your information as it's coming in and make sure that you're actually receiving what you expect to be receiving for information. Okay. Now, in the loop function, we're going to create a local variable to capture the state of the line following sensor. Okay. So we're going to create a special variable, whatever you want to call that. Make sure it's descriptive of what we're doing here. But basically we're going to read that signal coming in from the line follower sensor, store it in the variable. Then depending on what information is in that variable, we'll be able to determine if it's high, basically meaning is the sensor encountering a light area, or is it low, indicating the sensor is encountering a dark area. Okay, so we're going to do that first. Again, use the serial monitor to kind of check that variable, make sure it's giving us information and what information it's giving us, so you know what to use for the rest of the program. And then finally, using that information, you're going to turn on the LED on when the line follower, of course, sensor has encountered a dark area, in this case the line, or off, which is below when the line follower has encountered a light area. All right. So again, write your comments, write your code, and then see if you can get it to work. All right. So check it out, troubleshoot your code in your circuit, make sure you can get everything working. Okay.